In the recent past, the term machine learning has been a buzzword, and knowing its potential, machine learning is considered to be the next big thing for the near future. It may be a surprise to many that this trending buzzword, machine learning term, was very firstly defined way back in late 1950s by a famous computer scientist, Altair Samuel. He defined machine learning as a field of computer science that gives the computer the ability to learn without being explicitly programmed. Explicit programming is a traditional way of programming which requires a developer to introduce new variables into the source to capture a system behavior explicitly. Based on his studies, Dr. Samuel wrote the first computer learning program, which was for a checkers game. The programming helped the computer improve its game the more it played. It enabled the computer to have a self-learning ability. This unique ability was embedded in the computer by studying the moves which made up the winning strategies and incorporating those moves into the program. It is to be noted that these strategies were explicitly programmed by the programmers based on their knowledge and skills and fed into the computer system. Thus, it can be said that in earlier days, machine learning process was based on knowledge-driven approach. In the early 1990s, with the evolution of better computers and processing capabilities, there has been a shift in the approach of machine learning process. The shift is from knowledge-driven approach to the data-driven approach. The data-driven approach requires less upfront knowledge but a lot more back-end computation. In this approach, the decisions are made based on the pre-existing data. The computer programming analyzes large amount of data and draw conclusions from the result, which is considered as the learning process. This learning and predicting the outcome for the given input in the machine learning process is based on recognizing the data pattern or trend from the fed data. These trends are determined by using statistical tools. For instance, the fed data can have an uptrend or downtrend, which can be a linear or non-linear as well. Once these patterns are identified by the machine learning algorithm, backed by the statistical method, it can easily predict the future outcome based on these trends. It should be noted that for creating the predictive analysis and predicting the future outcome, we can use the traditional programming method as well as the machine learning method. To understand how machine learning differs with the traditional programming, let us understand these two separately. The traditional programming refers to a method of manually created program that uses input data and runs on the computer to give the required output. It is a manual process where programmers feed the set rules as the instruction in the computer system. Thereafter, the input data containing the system characteristics are fed into the program, and based on the set rules and conditions, computer processes the data to determine a pattern or trend in the data. This trend is further used for predicting the outcome as the system responds. On the other hand, in machine learning process, the data containing the system characteristics and system performance, which is the expected outcome, is fed into a computer as an input. A computer algorithm then uses these data for training purpose, which is considered to be a learning process, and gives output in the form of a program, that is, the set rules in the coded form. This program is then further used for predicting the system performance for the future dataset. In order to understand the machine learning process better, let us know the various categories of machine learning. In general, machine learning is commonly classified into two types: supervised learning and unsupervised learning. Supervised learning is a method of training the machine learning model with the help of an input vector and its supervisory signals. In this method, the model analyzes the training data and determines a function that can map the relation between the input and output data, which can be used for predicting the new unseen data. The creation of the mapping function is an iterative process where the machine learning model analyzes the data, makes a prediction, compares the actual output to determine the error percent, and repeat the process till the error is minimized to an acceptable level. Unsupervised learning is a method of training the model where input vector do not have any supervisory signals. It is a data-driven learning process in which the given set of input data do not have any defined label, and the outcome is dependent on the characteristics of the data and considers probability densities of the given input. To understand these two methods, let us take some examples. Consider that a predictive model is to be created, which can predict the categories of different motor vehicles based on the given inputs. In the supervised learning process, the supervisory signal will be a set of data that contains the different varieties of motor vehicles such as bus, car, bike, or Formula 1 car, which is considered as the target data. Each of these categories are labeled appropriately and their system characteristics such as shape, size, number of wheels, etc. are well defined. These system characteristics are considered as input variables. This whole dataset is considered as the training data. Based on this data, the machine learning model is trained, which correlates the relationship between the input variable and the target data. This trained model is then used for performing the predictive analysis, which means if in future a set of system characteristics similar to a bike is fed into the model as an input data, then it will map these new data set with pre-existing data and give the outcome response as bike. Supervised machine learning can only be used where the input data are labeled systematically. Its application can be seen in email spam detection, fault detection, image recognition, etc. In unsupervised machine learning method, the training dataset is not labeled. In this method, the system characteristics are fed into the system as the input variable with no target data. The training model then processes these data and determines the properties or patterns in these data, which is further used to learn the group or cluster formation. The newly organized clusters are the set of data with similar properties. When any new data is fed into the model, based on the similarity index of the existing data, the new data is categorized and the outcome is predicted. The unsupervised machine learning is used when the available data does not consist of any label. It is commonly applied in the field of face recognition, text mining, big data visualization, etc. Both supervised and unsupervised learning are widely used in machine learning process, and their selections depend on the available data type. After knowing the categories of machine learning and its field of application, it is now important to understand the different steps that are involved in machine learning process for creating the predictive analysis. The complete machine learning process can be divided into 7 stages. The process begins with data acquisition. The data acquisition is a technique of gathering information from a variety of sources in a predefined form. The data can be in numeric values such as age, annual turnover, temperature, loan, income, etc. Or it can also be in the textual form such as color category, gender, level of study, emotional feeling, etc. The second step is of data curation. It is a process of cleaning up and correcting the raw data if there is any discrepancy in it. Data curation can be further subdivided into 3 stages, that is, data analysis, data cleaning, and data transformation. Each of these stages ensures that the raw data does not have any inconsistency or errors, as the high quality data results in improved accuracy of the machine learning model. The data curation is followed by the data exploration stage. The exploration deals with the analysis of the data and computing the mean standard deviation, median, and mode for the curated data. The data exploration helps in getting insight into the data, which helps in determination of which statistical tool or algorithm to be selected that improves the efficiency of the machine learning model. The next is model creation stage. It is a process of creating the algorithm which can process the curated data and formulate the mathematical equation that is best fit for the dataset. The model creation is based on the statistical modeling, and its selection majorly depends on the data insight obtained during the curation stage. In the 5th stage, model training, the curated data is fed into the machine learning model for the training. The model training is a learning process in which the model correlates the input variable with the target data for predicting the outcomes. It should be noted that in the majority of cases, the whole curated data is not used for training. Only part of it is used. In general, 70 to 30 ratio is used. That is, 70% is used in training and 30% is used in model testing. Model evaluation follows the model training stage. Model evaluation is a method of checking the performance of the trained model. The untrained testing dataset with a known outcome is used in the trained model to predict the outcome. The predicted outcome is then compared with the known outcomes, and error percentage is determined to evaluate the model performance. Prediction is the final stage of the machine learning, which refers to the deployment of the trained model for getting the desired outcome. It relates to the process of forecasting the likelihood of the outcome on the historical dataset. It is a step of getting answers by utilizing the dataset and the model. All these 7 stages are followed in machine learning process for performing the predictive analysis, and each stage has its own importance.